Well, now we're going to start on do section 1.9, which is one of my most favorite exercises. It's on data representation and different ways to represent data that's important to you. There's a frequency distribution, grouped frequency distribution, histograms, and then stem and leaf charts. All right, so let's look at our first example. 30 random people at a subway station in New York City were asked what their most common source of news is. The Times, the Post, the Daily News, or some other source. Now, first of all, do you think this would be a representative sample for all New Yorkers? There are different types of answers here. I would say probably not, because New York's a massive city and just 30 people is a pretty small sample. Plus, who knows how centrally located or what kind of neighborhood that subway station was in. So that probably affect maybe where people get their news source. But anyway, you can have your own opinions on that. But down here, responses are summarized below. Construct a frequency distribution chart. Constructs frequency distribution for the data. All right, so this is what our final frequency distribution is going to look like. There's only two types of information. So first of all, we're going to have the category or the news source. And there are 4 of them. The Times, the Daily News, Post, and the last category we will call Other. And here will be our frequency, how many times someone gave that as their answer. So we'll do our work on the side here and just put our final answers in our frequency distribution chart. So we're going to do the tick method. Every 5th tick is going to get a cross. So here we have Times, Daily News, Post, and Other. 1 for the Times, 1 for Other, 1 for Other, 1 for Daily News, 1 for Post, 1 for Post, 1 for Other, 1 for Post, 1 for Time, 1 for Daily News, 1 for the Times, 1 for the Post, 1 for the Daily News, another for the Daily News, for Other. Okay, so we're right here. 1, 2, 3, 4. Every 5th, we're going to put a cross tag or a cross slash so that we know that that's a group of 5. And then here's Other. And now Daily News is going to get their 5th. And Post is going to get their 5th vote. And then Other gets another. And then Daily News, and Daily News, and Other, and Other, and Times, and Post, and Post, and Post, and Other, and Other. So these are our totals. The Times got 4 votes, if you will, 4 of the 30 people. The Daily News got 7, 5, 6, 7, 8. The Post got 8. And then other sources, 5, 10, 11. So the Times got 4. The Daily News got 7. The Post got 8. And Other got 11. So we would want to add these up and make sure they add up to 30, just to check to make sure we accounted for all of our data. So 19, 26, 27, 28, 29, 30. Yep. So what single source do you think was most common source of news? Well, probably the Post, because 8 of those 30 people picked the Post. Now, the other category says 11. That includes all other categories. If there was a newspaper as popular as the Times, the Daily News, and the Post, you'd think it would have gotten its own category. So the truth is, we can't be sure. There might be a single source included in this other that got more than 8 votes, but we're thinking probably not likely. So this is called a frequency distribution chart. On the bottom of page 131, it talks about inflation rate comparisons between numbers. In other words, $65,000 in 1980 wouldn't be like $65,000 in 2015 because of inflation. So something that cost $100 in 1980 might be more like $350 in the year 2015. But we're going to go into our second example. And this example is in billions of dollars, inflated, adjusted dollars. So they looked at the advertising revenue, the amount of money that came into the American newspaper for advertising since the year 1980 to the year 2015. And these are all inflation adjusted. So this would be $42.9 billion in 1980. And then we're down to $17.9 billion in 2015. So here we are asked to build a grouped frequency distribution. Rather than every category getting their own row, categories are going to be grouped. So here we want a grouped frequency distribution for the data. And the first class should be between 10 and 19.9 billions of dollars, and all others should be the same size. All right, so I'm going to look at our data and build a type of frequency distribution, but this is a grouped frequency distribution. So we still have 2 things here. We'll have the class or the category, and then we're going to have the frequency, the number of times the answer was in that class. So they told us the first one is from 10 to 19.9 billion. So the next one's going to be from 20 to 29.9 billion. And then we're going to have 30 to 39.9 billion. So this is going to be the teen billions, the 20 billions, the 30 billions. Here we have the 40 billions. And from 50 to 59.9, here we're going to have the 50 billions. And then 60 to 69.9 billion. So just like before, we want to tally our answers over here and then just put our final results in our grouped frequency distribution. So we'll put our classes over here, 10 to 19.9, 20 to 29.9, 30 to 39.9, 40 to 49.9, 50 to 59.9, and 60 to 69.9. And then we're going to, again, put our ticks, every fifth being a slash. So 42.9, 42.8, 42.3, that's the third tick, 48.3, 52.5, 55.1, 56.9, 61, 62.1, 62.8, 58.1. Now for 52, we're going to put a cross slash because every fifth, this is going to make it easier to count them at the end. Then there's a 51, 51.6, a 53, a 55, and our 57 is going to get its cross slash. 59, 62, 64 is going to get its cross slash. 66, 58, 56, 58, 60, 59.8 is going to get its third cross slash. 57.3, 51.7, 41.6, that's going to get its first cross slash. Then we have a 30, and a 27.6, and a 25, and a 22.3, and a 20.7, and then 19.4, and a 17.2. All right, so this class had 2 votes. I'm sorry, 2 numbers in that number of billions. And this class had 4, 2, 4. This class had 1. This class had 5. This class had 5, 10, 15, 16, 17. And this class had 5, 6, 7. So this will be a 2, 4, a 1. I'm just putting the values in my final chart here. From 40 to 49 was 5. From 50 to 59 was 17. And from 60 to 69 was 7. So which class contained the most number of values? Well, easily the 50 to 59.9 billion in annual revenues. Got the most number of years between 1980 and 2015. So write a sentence explaining what this means. So this would mean something like the total annual accompanying revenue, the total annual income from advertising was between 50 and $59.9 billion. Let's say the most common total. That's each of these was the total annual income, but the most common one, the one that occurred most frequently, was between 50 and 59. So that's a group frequency distribution. And so now here they want us to draw a histogram for this advertising revenue. Don't forget to fill in the axes. You should also include labels. All right, so I'm going to put down here ad revenue in billions. And that'll be 10 billion, 20 billion, 30 billion, 40 billion, 50 billion, and 60 billion. So from here to here would be 10. From here to here would be 10 to 19.9. From here to here would be 20 to 29.9. And then if we look at this data, that's going to be the number of years or number of occurrences. Number of occurrences. Or you could put frequency. We're going between 2 and 17, 2, 4, 6, 8, 10, 12, 14, 16, 18. Perfect. 2, 4, 6, 8, 10. Oh, sorry. 10, 12, 14, 16, 18. Okay, so 2 occurrences happened between 10 and 10.9. 4 years were between 20 and 20.9. So this will be our bar chart. Only 1 year between 30 and 39.9. 5, here's 2, 4, 5. That's going to be back there. And then we jump up to 17. Up there. That's by far the most frequently occurring advertising values, advertising income. And then down to 7, between 60 and 69.9, we're going to go to 7. As that will be your histogram. So we learned frequency distribution, grouped frequency distribution, and histogram as a modeling technique.